So my learners have been with me for 6 weeks and we've installed our first lighting circuit, which is a one-way lighting circuit. The effort to connect the consumer unit, the batten lamp holder and the one-way switch are identical to that in industry. However, we know the effort to get the cable from the distribution board to the light and from the light down the switch would be vastly different in industry. So the connections are the same, the effort to put the cables in isn't. The test we're going to carry out is also identical to the one that we would carry out into industry. However, our readings will be phenomenally small because of the short cable, therefore the limited amount of resistance we'd have in circuit. The first test we're going to carry out is the continuity of the CPC. I want to prove that the CPC gets from the consumer's unit to the lighting point and also down to the switch. We should perform this test at every single lighting point and switch on a circuit. We only have one light and one switch on ours. However, if in industry you had 10 lighting points with 10 switches, the test would be carried out at every light and every switch. And as we progress from the consumer unit to the first room, second room, etc., we expect to see the reading increase as we get to the furthest point of our radial circuit. The further we are away from the consumer unit, the more resistance offered by the cable. We will also include at the same time the polarity test, proving that the switch will operate the light. So we're going to perform that test next. I'm going to set my instrument up and see how we can get on with that. We're using the Megger MFT tester, and in order to do a continuity test you must use the red and green located holes in the top. It wouldn't matter if I used the blue lead, but I've still got to use L1 and L2, which are represented by red and green. So I am going to use my red and green leads. So in we go. And because the leads themselves are also made of copper, as is our link, we're going to need to remove the resistance of these during this test. I need to set it on to ohms. In this case it's in an orange square here and it's got the omega symbol, so I'm going to need to rotate it round to ohms and see the instrument come on. And now what I'm going to do is link together both the link itself to prove it isn't broken and remove its resistance onto my crocodile clip like so. And we can see they have a reading of 0.01. You press the test button only once, and I've now got a reading, in this case, of 0.11, which isn't 0, so I need to press it just once again. And now I have 0. Be very careful with this instrument that it isn't 0 flashing. If the 0 is flashing, it is below 0 and would need the test button pressing at least once more. We have 0, we've removed the resistance of both the leads and the link, therefore we're ready to start the continuity of CPC and polarity test. So first of all, I'm going to remove the line conductor out the top of the circuit breaker for the circuit that is under test. I've only got one circuit here, so for my B6, for my lighting circuit, I'm just going to disconnect my line conductor. Then I'm going to use my crocodile clips to link the disconnected line conductor to the earth bar. It doesn't matter where the crocodile clip goes. This is a solid brass bar, so we can clip anywhere on it. We don't have to clip directly on top of the screw to the CPC that we've got. Let's disconnect my line conductor and I'm going to connect it to the earth bar. So I've disconnected my line conductor under test, I've connected to my earth bar, so I'm going to perform the continuity of CPC test now at my lighting point and then my switch. Remembering if I had more than one light and more than one switch, I would do it at every point on the circuit. The link is connected in our consumer unit and we've walked out into the installation. In this case we only have one lighting point. So we're going to go to that lighting point and connect between the switching line and the earth terminal where the CPCs are connected. Remembering we're only on week 6 with my learners and it is a bayonet cap lamp holder. We know as we move forward that if this was an Edison screw, we'd need to prove the polarity from within inside the lamp holder itself, making sure the centre pin is line and the screwed part is neutral. We're at a stage where we're just introducing testing. So I'm going to clip onto the earth terminal and onto the switching line, try and keep everything out of the way so you can see what we're doing. And I've got a reading of 0.13 of a 12 of an ohm, so 0.12 of an ohm. We have a low resistance reading, therefore the circuit is in the on position. If I turn it now off, we see we have a reading which has gone off the scale, so in other words an open circuit, the circuit is off. Turn it back on, we have a low reading ohm of, and it's settled down now at 0.14 of an ohm. By operating the switch we prove polarity. We must leave it in the on position for insulation resistance test, which is coming later in the sequence. But that isn't it finished. We've only proved the CPC has made its way to the, in this case, batten lamp holder. We've also proved it turns on and off. We must make sure there is also a CPC at the switch, because both accessories could be changed for exposed conductive parts. So in other words, a metallic light fitting or a metallic switch. So let's test it next at the switch itself. So we left the switch in the on position when we tested the batten lamp holder above. I've connected onto the earth terminal in the back of the lighting pattress, and I'm going to probe onto the line conductor. This time we get a reading of 0.1 of an ohm. That is less than the reading we got at the light fitting, which is the furthest point on the radial circuit. We'd record the highest reading, so we were recording a reading of 0.13 of an ohm for our continuity reading. There is no need to operate the switch at this stage. We only operated the switch when we were proving polarity of the light. We don't need to operate the switch when we're actually at the switch itself. So to recap then, we linked line and CPC in the distribution board itself. So the line conductor in the test, in this case the one for the lighting circuit, was linked to the earth bar. We only had one lighting point and one switch. Went to the furthest point, in this case of the radial circuit, and we tested between switching line and CPC, and we got a reading of approximately 0.13 of an ohm. We operated the switch at the same time we were there, and we saw full scale deflection of the instruments and went from the reading to infinity and back again. We left it in the on position before we go down to the switch. The switch we tested between the line conductor and the CPC secured in the back of the box. We got a reading of 0.1 of an ohm. We record the highest reading in circuit. So we were going to record under our continuity box heading 0.13 of an ohm for this circuit that I've tested. We're going to record it under the box heading R1 plus R2. R1 represents the line conductor and R2 represents the CPC. So we've linked together R1, the line conductor, to R2, the CPC, and we've measured the continuity of that path. We've also proved polarity at the same time by operating the switch, and we left the switch in the on position ready for the next test for us, which will be insulation resistance. Remember, if you have more than one lighting point and more than one lighting switch in a circuit, you must test at every lighting point and every switch on the circuit in order to prove the CPC gets to each point in turn and prove polarity. Recording the highest reading, logically at the end of the circuit on a radial circuit. However, it would be the highest reading wherever you achieved it that you would record.